Hello students, welcome to this video. Here we are going to discuss about solar radiation measuring instruments, in particular with module number 3, solar energy and energy engineering. So we will study what are the various instruments which is used for solar radiation measurements. Okay. Uh, Measurements of solar radiation are very important because uh, the increasing number of solar heating and cooling applications and the need for accurate solar irradiation data to predict its performance as well as to design solar measurements are very important. Okay, so experimental determination of the energy transferred to a surface by solar radiation uh, required instruments which will measure the heating effect of direct solar radiation and diffuse solar radiation. Okay, so measurements are also made of beam radiation which respond the solar radiation received from a very small portion of the solar sky. Okay, so or circumference of the solar sky. So a total radiation type instrument may be used for measuring a diffuse radiation alone or individually by shading the sensing element from the sun's direct rays. There are two basic types of instruments are employed for solar radiation measurement. One is called as a pyrheliometer and second one is called as pyranometer. Okay, pyrheliometer, which represents or which culminates the radiation to determine the beam intensity of as a function of incident angle, and the pyranometer measures the total hemispherical solar radiation. The pyranometer measurements are the most common type of solar radiation measuring instrument. The total solar radiation around the outer edge of the atmosphere is called solar constant, that is already we studied. So we will try to see first pyroheliometer in that aspect. Uh, so pyroheliometer is an instrument which measures beam radiation, as I mentioned earlier. In the contrast to a pyranometer, the sensor disk is located at the base of the tube whose axis is aligned with the direction of the sun rays. So the diffuse radiation is essentially blocked from the sensor surface. Okay, so most pyroheliometer used for routine measurements of operate on the thermopile effect uh, and are similar to pyranometer in this respect. Okay, so they differ in that mechanically they must follow the sun to measure only direct sunlight, and it will avoid the diffuse radiation or diffuse component. Okay, so most in practice, direct solar radiation is measured by attaching the instrument to an electrically driven equatorial mount for tracking the sun. So this is the diagram. So you can able to see here. Uh, it consists of this pyroheliometer measuring beam radiation will consist of uh, uh, a tube which is blackened on inside surface, a baffle, some baffles which will obstruct the or directs the flow or the solar radiation. Then it is having a alignment indicator, It's having black absorber plate that you can able to see, and the thermopile junction you can able to see there, number 5. And number 6 is two axis tracking mechanism. Okay, so the diffuse component is avoided by installing the a collimator tube over the sensor with a circular cone angle of about 5 degree. Okay, so you can able to see that cone angle acceptance angle only about 5 degree. Okay, so uh, the problem with pyroheliometer measured are several fold. The aperture angle or except the circumference solar contributions or and imprecision in the tracking mechanism is foremost drawback. The first two problems are almost impossible to eliminate because the inability to define solar disks precisely and the finite dimensions of the instrument components. So you can able to see there how it we will try to see how it will work. So pyrometer is used to measure the direct solar radiation from the sun and marginal periphery. To measure the direct solar radiation correctly in receiving surface, uh, it must be arranged to be normal to the direction. Okay, so for this reason the instrument is usually mounted on sun tracking device called an equatorial mount. So here, well, as I mentioned, it is used for direct beam radiation to measure beam radiation falling on surface normal to the sun rays. In contrast, pyranometer, the black absorb plate or hot junctions are is located at the base of the culminating tube. That it is a two-axis tracking mechanism and a line indicator is also there. So in using this, it's having a black absorber plate and which is having shaded strip. So when solar radiation is falling on it, the thermocouple or thermopile junction will read the uh, data, and by using that uh, we can able to measure uh, the solar radiation. Next is about pyranometer, which is an instrument which is measures total or global radiation over hemispherical field of view. Okay. If a shading ring is attached, the beam radiation is prevented from falling onto the instrument sensor and then measures only the diffuse component of the radiation. So you can see the sketch where pyranometer is shown. So it's having a black surface, glass domes, which is guarded with the plates and leveling screws in order to maintain the level. Mounting a plate and bolt, which is fastened with bolts to the platform. Okay, so in most pyranometer, the sun's radiation is allowed to fall on a black surface. Okay, to which the hot junctions of a thermopile are attached. The cold junction of the thermopile are located in such a way that they do not receive the radiation. As a result, their EMF will generate, which is proportional to the solar radiation falling on it. So this EMF, which is usually in the range of 0 to 10 millivolt, which can be read and recorded or integrated over a period of time with the regular calibration of about plus or minus 2% can be obtained. Uh, the sensor has a horizontal radiation sensing surface that absorbs solar radiation energy from the whole sky with a solid angle 25 steradian SAR. so and transforms this energy into heat. Okay, so global solar radiation can be ascertained by measuring this heat. Okay, so the following there are some types of pyranometer, which is pyranometer, yellow solarimeter, okay, which is like a photovoltaic solar cell, and thermoelectric pyranometer, etc. Okay, as I mentioned earlier, pyranometer consists of a black surface which heats up when it is expected to solar or when it is exposed to solar radiation. So its temperature increases until the rate of heat gain by solar radiation equals the rate of heat loss by convection or conduction and radiation. So with this, the hot junctions of thermopile are due to the hot junctions of thermopile are attached to the black surface. The cold junction is located under a guard plate that you can able to see in that sketch, so that they do not receive the radiation directly. So as a result, uh, an EMF is generated. So you know this EMF, which is usually in the range of 0 to 10 millivolt, can be read or recorded. Okay, and the pyranometer can also be used for measurement of diffuse radiation. This is done by mounting it at the center of this semicircular shading ring. So the shading ring is fixed in a such a way that its plane is parallel to the plane of the path, and sun's daily movement across the sky, and it shades the thermopile element and two glass domes of pyranometer at all the times from the direct sunshine. Next is about sunshine recorder. So the duration of uh, bright sunshine in a day is measured by means of sunshine recorder. So the sun's rays are focused by a glass sphere to point on a card strip held in groove in a spherical bowl mounted concentrically with the sphere. So this can be measured with the help of Campbell stroke sunshine recorders. So the principle and the structure of this sunshine recorder is like this. You can able to see the sketch. A Campbell Stokes sunshine recorder concentrated sunlight through the glass sphere onto a recording card, which is placed at its focal point. Okay, so the length of the burn trace left on the card represents the sunshine duration. Okay, so the device structure is shown in that figure. So homogeneous transparent glass sphere is uh, supported on an arc and is focused so that an image of the sun is formed on recording paper placed in a metal bowl that you can able to see, the which is attached to the arc. The glass sphere is concentric to this bowl, which has three partially overlapping grooves, three partially overlapping grooves. Okay, a spherical bowl with the grooves that you can able to see, into which recording cards for use in the summer or winter or spring, and mm, that atom are set. Okay, three different recording cards are used depending on the season: summer, winter, and rainy season. Okay, or spring, uh, that rainy season. The uh, focus shifts as the sun moves, and burn trace is left on the recording card at the focal point. Okay, at a particular point of point indicates the presence of sunshine at that time, and the recording card is scaled with the hour mark, so that exact time of sunshine occurrence can be found. Okay, so measuring the overall length of burn traces reveals the sunshine duration for the day. For exact measurement, sunshine recorder must be accurately adjusted for a planar leveling. So leveling is very important. Okay, and meridional direction and latitude. These are very important things. So you can able to see there actual sunshine recorder in figure number A and B. So it is there is no does not require any electric power. That is one, and it is there is no moving part, so it is most advantageous over all other measuring instruments.